Okay, gentlemen, so today I will be going over questions 7 through 12 that I'll deal with this first, this equation, C3H8, propane reacts with oxygen gas, water and carbon dioxide are formed. So I'm going to go over each of these step by step, and this will cover pretty much everything we did. So finding out limiting reagent, finding out how much excess reagent is left over, finding percent composition. And it will go back and, of course, use the basic stoichiometry we learned last week. So if you can do everything in this problem or the first set of questions above it, this one, if you can do all that stuff and know what you're doing, you're fine. Remember, you have a how-to sheet to go by step, and so you can follow that along as I do these. The first thing, number 7, and these questions kind of guide you step by step through everything. The first step is to write a balanced equation. So, balanced equation for this, well, first of all, color I like, and there we go. First of all, so you have to know, actually you don't have to know because it tells you, C3H8 plus O2, remember oxygen gas is O2, gives you H2O plus CO2. Now, you should be able to recognize that as a combustion reaction. So this is a combustion of a hydrocarbon, makes water and CO2. So I'm going to balance it really quickly and come back. So our balanced equation is 1 methane plus 5 oxygens gives us 4 waters plus 3 CO2s. On each side, there are 3 carbons, 8 hydrogens, and 10 oxygen atoms. So that's, make sure you're comfortable balancing equations. You need those numbers, those coefficients, the 1, 5, 4, and 3 for the next step. So the next step says if 22 grams of propane react with 20 grams of oxygen gas, how much CO2 can be formed? Well, since you're given 2 amounts, the amount of each reactant, this is a limiting reagent problem. You have to figure out which one makes more and which one makes less. And the one that makes less, that's how much you make, because at that point we run out. So we're going to go, and I'm going to convert from 22 grams of propane to grams of CO2, and 20 grams of oxygen to grams of CO2. So I'm going to set up those 2 separate stoichiometry problems. So if you set up the 2 stoichiometry problems, going from 22 grams of propane to grams of CO2, and then 20 grams of oxygen to grams of CO2, using the correct balance equation. And again, you're just converting grams to moles, using molar mass, and then moles of one chemical to moles of another chemical, and for that you use the coefficients on the balanced equation. So 3 moles of CO2, because CO2 has a 3 in front of it, 1 mole of propane here, because propane has a 1 in front of it, and on this equation, 3 moles of CO2, again 3 in front of it, and 5 moles of O2, because O2 has a 5 in front of it. And then you convert that into grams of CO2, and you find out you have enough propane, C3H8, to make 66 grams of CO2, but only enough oxygen to make 17 grams of CO2. So that oxygen is what's going to limit you, because after you make 17 grams of CO2, you run out of oxygen, and that's the end of the reaction. So the limiting reagent would be O2, would be this oxygen. So that's your limiting reagent. The next question asks how much excess is left over. So this is one of those problems we learned about, or I talked about in the video yesterday, how much excess is left over. So we know we're going to use up all 20 grams of oxygen, and we're going to make 17 grams of CO2. And at that point, the reaction will stop. But we have enough propane, C3H8, to make 66 grams of CO2. So there's clearly going to be some extra propane. So how much extra? What we want to figure out is how much propane we use when we make this 17 grams of CO2. So we're going to convert from the theoretical yield, the amount we actually make, to, so 17 grams CO2 back to grams of C3H8. So you're going to convert from grams of theoretical yield back to grams of excess reagent. And that will tell you how much excess reagent you used, and you know how much you started with, so then it's a subtraction problem. So it'll be one stoichiometry problem followed by a subtraction problem. So I'm going to set up the stoichiometry problem and finish it, and then we'll talk about it. Okay, so I've set up the stoichiometry problem going from 17 grams of carbon dioxide, converting to moles, then from moles of carbon dioxide into moles of propane, our excess reagent, and then back to grams. So grams of carbon dioxide back to grams of excess reagent. We find out that when we make those 17 grams of CO2, what we use is 5.7 grams of C3H8. So that's how much gets used. If we know how much we used, and we know how much we started with, we can figure out how much we have left. So we started with 22 grams, because that's what the question tells us, and we use 5.7 grams. So it's just a matter of subtracting, and we find out we have 6.3 grams of propane left over. 16.3 grams of propane left over. So whenever you're asked how much of the excess reagent is left over, it's a stoichiometry problem plus a subtraction problem. Don't forget to do the subtraction problem, because you'll have done the hard part, the stoichiometry, and then you'll be wrong. If you just said 5.7 grams, that'd be wrong. That's how much got used. You have to subtract that from what you started with to figure out how much is left over. So that is number 10. Number 12 asks how many grams of each product will be produced from this reaction. Well, you already know how many grams of CO2 are going to be produced from this reaction. So this reaction makes CO2 and H2O. We already know that we're going to get 17 grams of CO2. We have to figure out how much water we're going to get, which is another stoichiometry problem. Now, you don't have to do two more stoichiometry problems. You don't have to figure out what the limiting reagent is. We already know that the limiting reagent is the 20 grams of oxygen. So that 20 grams of oxygen, if it's a limiting reagent for CO2, it's also going to be the limiting reagent for water. Once the reaction stops, it stops, and no more products are produced, regardless of what kind. So I can just find out, using the 20 grams of oxygen, how much water we can make. So it's another stoichiometry problem. So starting with 20 grams O2, and then we're going to convert that into grams of water. So I'm going to set that up, and I'll come back. Okay, so I set up the stoichiometry problem to figure out water. Again, you don't have to do both the 22 grams of propane and the 20 grams of oxygen. Once you know what the limiting reactant is, that's going to set how much product you make for every product you make. That's where the reaction stops. So how many grams of each product will be produced? Well, we already know the 17 grams of CO2. We figured that out in problem number 8. So to figure out the water, we take the limiting reagent, the 20 grams of oxygen, and convert it to grams of water, just using stoichiometry. So grams to moles, moles of one chemical to moles of another chemical, using the balanced equation. So water gets a 4 because it has a 4 in front of it in the balanced equation, and oxygen gas gets a 5 because there's a 5 in front of it in the balanced equation. And then we convert that moles of water to grams of water, and we finally get 9.01 grams of water. So we got 9.01 grams of water, 17 grams of CO2, and 16 grams of propane left over. That's exactly what we'd have at the end of this. So just from doing this math, I can tell you, you start with 20 grams of propane and 22 grams of propane, excuse me, and 20 grams of water. What you will have at the end is 17 grams of CO2, 16 grams of leftover propane, and 9 grams of water. And if you actually do all the calculate all the grams, you'll find that you started with 44 grams and you end with 44 grams because you cannot make or destroy matter. So question 13 is a percentage yield one. These are pretty easy questions. It says, if 8 grams are formed in the reaction described in problem 7, what is the percent yield? So remember, percent yield is just actual yield divided by theoretical yield. So percent yield equals actual divided by theoretical. To keep straight which one is actual and which one's theoretical, theoretical always comes from the math. And that, for whatever reason, that makes sense to me. It's theoretical, sounds like it would come from math. The theoretical one comes from the math, from the stoichiometry. The actual one is one that you actually got in the lab or ran the reaction or are given in a problem. So in this case, the actual would be 8.0 grams H2O. And the theoretical is what we just figured out in the previous question. We figured out that we would expect to make 9.01 grams H2O. And we'll figure that out. And for percent yield, you always multiply it by 100. I rarely show that step because I just do it in my head. But you should multiply it by 100 to get a percent. So it should be a percent, not a decimal. So 8 divided by 9.01 would give you 0.0887, or, and I'm rounding here, 89%. So you get an 89% yield from that. So that is how you do all these steps. If you can do everything in this problem that I've gone through, that's all of stoichiometry. You know everything that you would have to know for the stoichiometry unit. If not, remember, there's a how-to sheet. Work on being able to do this whole problem, or understand every step of this problem thoroughly. Okay, that's it for today. This worksheet that we're working on today is due Friday, and your lab worksheet is due Thursday. Your lab demo worksheet, the demonstration worksheet of the limiting reagent lab, it's due Thursday. Okay, have a good day, gentlemen.